sequence, you're adding or subtracting the same number over and over again. So those of us who were here yesterday, you guys already know we worked with some sequences that were already arithmetic, right? So we saw some where we just added the same number or subtracted the same number every time. Okay. Yesterday I said you have to think outside of the box. There's all these different sequences, right? And you just have to be thinking like, how are these numbers related? And now today I'm going to say, go back to a box. Okay, and in our little box for arithmetic sequence and series, we're going to say this box holds all the sequences where we're adding or subtracting the same number. Okay, so that's what it means to be arithmetic. Now, some of you may be taking issue with the fact that I'm saying arithmetic, and some people will see that and read it and be like, why are you not saying arithmetic, right? The real answer is, I don't know. My supposed answer, or what I think, is that arithmetic sequence, I'm using it like an adjective. So I'm describing something, whereas when I talk about arithmetic, I'm talking about a noun. So then you say them differently. That's all I can say. If you say I can't even say it. If you say arithmetic sequence, I kind of giggle a little when you say it. Because it's not how you're supposed to say it. Okay, so it's arithmetic. This is a mathematical definition for arithmetic. Think about putting it in your own words and then kind of push Nathaniel there. You're adding and subtracting the same number. What that means is that the difference between consecutive terms is constant. Consecutive meaning one right after another. So that goes back to like our recursive definitions. That whole idea of n and n minus 1 are consecutive, but so are k and k plus 1 consecutive numbers. Okay. So that means if you take the second term minus the first term, and notice I'm taking a later term minus a previous term, it should be equal to the difference between the third term and the second term, which should be equal to the difference between the fourth term and the third term, and so on and so on. Fifth term minus fourth term, etc. But I'm just going to say that's equal to D. Some number D. D is that difference. So we have a name for this. We call it in sequences, or arithmetic sequences, a common difference. So a lot of times today, I'm going to be asking you, what's the common difference? When I'm asking about the common difference, I want to know, what's that number we're adding or subtracting every time? Could you take a quick moment just to kind of glance down at your sequence and figure your common difference? So take the second term minus the first term. Is that the same as the third term minus the second term? The fourth term minus the third term? And then think about what number you're holding in your head for your common difference. If your numbers are going up from left to right in your sequence, your common difference should have been positive because you're adding the same thing every time. If your numbers are going down from left to right in the sequence, then your difference should have been negative. Okay, so in order for you to say that the numbers are going down, you'd have to put a negative in front of your difference. This slide has the formula for an arithmetic sequence. So today and tomorrow are going to be very kind of like formula heavy because we're going to work with arithmetic sequences in series, and then tomorrow we'll do geometric sequences in series. And this is the formula for the arithmetic sequence. I will say this. Have it as a tool to use if you kind of like run out of other options. But this is the one formula where I don't really use the formula. You know, we already did these types of sequences yesterday, and so we have another way of kind of like thinking about them. I think it's a more efficient way to think about how to write the rule for an arithmetic sequence. So this is one that you should know, be aware of in case you need it, but you might choose to use my method. And so I'll show you both methods on the example. Okay. The thing about the arithmetic sequence formula is there are really two pieces that you need to be able to plug into the formula and get a rule. One of them is a sub 1, which of course is the first term, right? So we'd really like to know the first term of the sequence. The other is D, which we just identified as our common difference. So again, the common difference is going to be very important. The other two things in the formula, n and a sub n, remember, for those of us who were here yesterday, I talked about, like, what if we wanted to graph a sequence? Then n would serve as, like, our x variable, and a sub n would be kind of like our output or our y variable. So those things, n and a sub n, should be left alone in the formula. So like if I'm writing a rule, I should see a sub n and I should see n, so then I can say, hey Nina, what's the 100th term? And she can plug in 100 and figure out that term. Okay. So on this first example, I'm going to use the formula first. I'm going to show you how the formula works, and we're going to get a rule for this arithmetic sequence, and then I'm going to show you kind of like more of the method we talked about yesterday. Okay. So if I know a sub 1 is 15 and I know d is 4, that's what I need to plug into my arithmetic formula for a sequence. So I'm going to just go ahead and plug it in. That formula that we just saw, a sub n equals a sub 1, the first term, which is 15, plus n minus 1 times t. And so I get n minus 1 times 4. Now, if you're using the formula, I would like for you to kind of simplify this out. You can always distribute your difference so that you get 15 plus 4n minus 4, and then that will leave you with two like terms that you can combine. So my rule for this sequence would be 4n plus 11. And that's how you can use the formula. If you like the formula and you prefer the formula, use it all the time. It's great. It'll always get you to the right answer. Okay. If I was not using the formula, so more like what we did yesterday, if I were starting this, I'd say a sub n equals, and we had an example yesterday, I think it was like 1, 5, 9, 13. And that was the example where we saw that it was going plus 4, plus 4, plus 4, plus 4. So a lot of us initially had written a rule like n plus 4. Do you remember that example that we did yesterday? Okay. And we said, well, that doesn't really give us what we want. We want to show like we're adding 4 many times, right? So I'm adding 4 once, and then I'm adding 4 twice, and then I'm adding 4 3 times. So how did we show that in our equation? That repeated addition. Kaylee? We wrote it as 4n because multiplication is repeated addition. So in this particular example, if you know what d is, if you know what the common difference is, then that's going to be your coefficient to your n term. Let's say my common difference was negative 2. So all my terms are going down by 2 each time. Then I would write negative 2n to start. So whatever my common difference is, multiply it by n, because that shows repeated addition. Okay? And then what we talked about yesterday was we would say, well, like, check your first term. If you plug 1 in for n, 4 times 1 is just 4. Is that what the first term really is? No, the first term is supposed to be 15. So what would I have to do to 4 to make it 15? Abby says? Add 11. And there we have the same rule that we found with the formula. Okay. So you choose what you like. Okay, you do it whichever way you prefer. I'm fine with either one. Okay. If you're having difficulty with our second method, then you should stick to the formula. Can you please look at your little sheet and create the rule? Don't write on your little paper, but create the rule for your sequence. You would maybe want to write it down like off in the margins of your notes or something like that, because I'm going to have you share it with your groups. Okay, so see if you can find the rule for your sequence. Okay, so what I want you to do next is you can get back together with your 3 or 4 people, whoever's in your small group, and you are going to share your rule and say it out loud like we would say it, like I would say it in class, so that you're practicing your language here, like a sub n equals 4n plus 11. Okay, so use that language. And then after you share your rule, I want you to verbally check a sub 5. So you have a 5th term in your sequence. We want to make sure that your rule is right, that it really gives us that 5th term. How would we check a sub 5? plug 5 in for n. Okay, so share your rule, check a sub 5, and then trade turns so that everybody gets a chance to share their rule. Go. Okay, let's come back together. I'm just going to read your letter for your sequence so you can verify that you have the correct rule. If you have letter A, it should be 4n minus 9. If you have letter B, it should be negative 3n plus 9. If you have letter C, 5n minus 4. And if you have letter D, negative 5n plus 15. Those of you who have the sequences where you're going down each time, you have to make sure that you include the negative with your difference. Okay? Excellent. Now, I'm going to have you go back to your small groups really quickly, and I'm going to let you guys kind of brainstorm. What if I don't give you the information you actually need? So what if I don't give you a sub 1, and what if I don't give you the difference? What if I tell you the 9th term of the sequence is 130, and the 15th term of the sequence is 40? Are you able to get any of the information that you need so that you can write the equation or the rule for the sequence? So think about, like, generally, if I want to write the rule, I'd like to have the common difference, and I would also like to have perhaps the first term. Okay, so see if you and your group can come up with any ideas about how you might be able to get either of those things. Okay, I'm going to call us back together and see if anybody has any ideas, anything you'd like to share. Can we get anything we want to write the rule? Rachel.
If you would subtract, like, you would subtract 40 from 130 and get the difference between those two, and then you would divide the difference by the number of terms that you're missing in between the 9 and 15. So you divide it by 6, and then that would be the difference between each number. So we got 15.
Okay, so you did this. Does it make sense that your difference is 15 if the 9th term is 130 and the 15th term is 40? It should be negative, right? So what could you change about how you calculated to make it negative? You should really do, like, you know, like when we're trying to find the common difference, we take the later term minus the previous term, right? So to really get the correct sign for your difference, you should take the term that comes later, which in this case is 40, the 15th term, and you should subtract from it the previous term. Because then that tells us to get from 130 to 40, we had to go negative 90. We actually dropped. So that would help you get the correct sign, but otherwise I agree with that. And then you said divide by the number of times you moved, or the number of times, the number of terms that there would be. So that would be divided by 6, which that would give us negative 15. So that could be a formula for the difference. What does that look like that you have already done many times before? Finding slope. Okay, so we kind of talked about this a couple of times yesterday, in that when you're working with something where it's going up or down by the same number, if you're going up 4, up 4, up 4, that kind of acts like a slope because you're going up 4 for the next term, but you're also moving right 1 to get to the next term. So you are really just calculating a slope. Arithmetic sequences, when graphed, look like linear functions. They look like lines other than the fact that they're non-continuous. They're discrete. So they would have a constant slope. So you are basically finding slope. I think that's a great way to kind of start that problem. Now, was any group able to talk about, like, how you could use the difference of negative 15 to help you get the rule? There are many answers here. Any ideas floating around out there? Maddie?
So you have a sub n, couldn't you plug, like, a sub 9 into that, and then write, like, 130 equals a sub 1 plus, in parentheses, 9 minus 1 times negative 15?
So you are modeling this after our rule. A sub n equals a sub 1 plus n minus 1 times d. And see where she's getting her number 130 and 9? When you have this set, remember I talked about this for graphing as well. This sub number is your n value. It's your a sub n, so n is 9. And then this number right here is what a sub n is. Okay, so that could be my a sub n. Could we have used 15 and 40? Certainly. Okay, but yeah, it'd be like when you're trying to write the equation of a line and you plug in one of the points, x and y, with your slope, right? Now we're plugging in one of our points in the sequence, and we have that formula, so we could use it. So then I would get 130 equals a sub 1 plus 8 times negative 15, and that's 130 equals a sub 1 minus 120. Add 120 to both sides, and we just found out that a sub 1 is 250. And so now we have a sub 1, and we also have d. Can we write the rule? Sure. I'll come back to you here in just a second, Eric. So I'd write the rule a sub n equals, I'd start with negative 15n. This is the way I like to do it. Can you plug back into that formula? Certainly. Okay, so if you like the formula method, use the formula method. If I check a sub 1, and I'm going to do this kind of mentally here, negative 15 times 1 would just be negative 15. But I really need my first term to be 250. What would you have to add to negative 15 to make it 250? 265. You'd have to add 15 to get back to 0, and then you'd have to add 250 more. So put a plus 265 on the back of your rule, and this should work. Okay, now, Eric, you had your hand raised. Do you have a different way to do it?
No, I just had like an observation. Isn't this just finding like a y-intercept for a linear equation?
Sure. Did anybody else have a different way of getting there besides what Madison did? A lot of people in my previous classes and I'm very pleased that you went back to the formula. So see how the formula could be helpful. A lot of people in my previous classes said, couldn't I just like count backwards from a sub 9? Like if a sub 9 is 130, can't I say a sub 8 is 145? This is so funny. A sub 7 is 160. And that's a truly valid method. Now for me, 9 terms, that's too many. I'm going to get lost, right? So then some people even amended or thought of before we thought of that idea. They said, well, if you want to go back to a sub 1, how many steps back are you actually taking to get to a sub 1? 8, right? There's a difference of 8 between the first term and the 9th term. So couldn't we just like multiply our difference by 8 and then add it back to that number? And notice that 8 shows up in Madison's work. So yeah, that would also work if you prefer to do it sort of like less formulaic method. Either one works. Good. We've talked a lot about arithmetic sequences. Now we want to talk about series. So this is the formula for the arithmetic series. On Friday, you must know your formulas. So you decide how you learn formulas. Like, do you write them down? Do you say them out loud? Do you put a Post-it on your bathroom mirror so you can look at it while you're brushing your teeth every morning? Do you just do your homework? Like, what is it that helps you learn the formulas you need to know? You decide.
Do you want these back?
Later. No, not right now. Thank you. Okay, now, this is a formula for a series. Remember, what's a series? From yesterday? Say it out loud.
Sum of terms in
A sum. Okay. So instead of just coming up with like the terms in the sequence, which is what the rule for the sequence is, the series allows us to find the sum of a bunch of terms in the sequence, right? So that we could add them all together. This is the rule for the arithmetic sequence, which means all arithmetic sequences kind of work the same way, which is really kind of nice, so we can have a formula. In this formula, n represents the number of terms to add. Okay, so do you want to add 10 terms or do you want to add 100 terms? You decide. And then we'll also have like the first term here, and then we have the nth term, which really in this case represents like the last term you want to add. So if you want to add 100 terms, then you want the 100th term right there. Okay. Now, just to give you some context here, why this formula works and why I'm giving it to you, there's a story in math about a mathematician named Gauss. Okay. And the story goes that like in the 3rd grade, some elementary level, I don't know, the teacher is very frustrated with her students, and she wants to just keep them busy for a while. So she gives them the numbers like, I don't remember if it's 0 to 100 or if it's 1 to 99. Okay, so I'm going to say 1 to 99. So she gives them the numbers 1 to 99, and she says, add up all those numbers from 1 to 99. And think back to your third grade self. Adding up 100 numbers would take a while, right? Third grade? Okay, so she says, add up all those numbers. Be done with you. And then Gauss, this famous mathematician, does it in like 3 minutes. And gets on her nerves. Okay. So what did Gauss do? He does basically this formula. So he recognizes a pattern. 99. Is that why you guys are all staring at me?
Yeah.
Okay, I couldn't tell. You're so nice that you won't even tell me I'm wrong. This is what Gauss notices. If I add up the first term and the last term, I get 100. If I go to the second term and I add it with the second to last term, I also get 100. If I do the third term and the third to last term, I also get 100. And this pattern is going to continue, right? 496, 595, so on and so on. So what he does is he pairs the numbers together, and they all have the same sum. And he only has to multiply it by half the numbers that there are. That's how many sums there would be. Instead of all the integers, take half of it. And that's basically what this formula is. Take all the numbers you want to add, divide it in half, and then pair them up with their sums. Okay. So all arithmetic sequences will work that same way. Here's an arithmetic sequence. I'm not going to do the numbers from 1 to 100. Okay, that would be considered arithmetic because they're going up by 1. But here's an arithmetic sequence. I'm only giving you how many terms here? 7. I'm aware that you could just type these into the calculator, but we're going to use our formula. But notice that you could make the same observation. 1 plus 19 is 20. 4 plus 16 is 20. 7 plus 13 is 20. The middle term is only half of 20 because it doesn't have a partner. Okay? So if I were going to use our formula, I would be adding the first 7 terms of this sequence. I would do 7 divided by 2, and I would multiply it by my first term plus my last term. And what that's going to do is say you have 3 full sets of 20 and 1/2 set of 20. So 3.5 times 20 gives me 70. I have a sum. And that took me a lot less time than I would have to take in my calculator 1 plus 4 plus 7 plus 10. Okay? So just plug in there. Okay. Here's another example. Do the sum of the integers from negative 10 to 50. Okay. Probably the hardest part about this question is figuring out the number of terms that we're adding, right? So for right now, I'm just going to say n. And what's nice about this is, do I know my first term? Do I know my last term? How many numbers are there? 60. 60 numbers? Yeah. Isn't 0 an integer? Okay, so some people are looking at me like, you're crazy. Why are you questioning me? This is the thing. I sometimes find counting hard. This is an example where for me, counting is hard. I really if somebody asked me how many hours I was at a place, I literally go 1 to 11, 11 to 12, 12 to 1. Okay, so sometimes counting can be challenging. So, just to kind of make this clear for everybody, I am going to count 10 numbers on my hand in this set. So I'm going to start at negative 10. Negative 10, negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1. So from negative 10 to negative 1, that is 10 numbers. Do you agree? I just count them on my fingers. Okay? So that means that 0 to 9, which is thinking back to probability, those are the next 10 digits, right? Okay? And then I would do 10 to 19 and 20 to 29, and you should be recognizing a pattern here, so that you would eventually have 50 to 59, and you would have 6 sets of 10, correct? So that's your 60, but then you need the one more. So in this particular case, you have to, I think when you do like, what is it? You do 50 minus 10 and then you lose the 10. So you have to add back the negative 10.
Is the bottom one supposed to be 40 to 50?
No, I just skipped 30.
But it only goes up to 50.
Oh, yeah, sorry. Yes, sorry. I was thinking 60, wasn't I? Okay. 40, 49, yes, thank you. Nobody else, I probably put 50 all the rest of the one, you know enough. Thank you. Okay, but yes, so there would be 6 sets and then 1 extra. So like this is just like a warning, like, yeah, it looks like 60, but be careful with your counting, right? Your one job on this problem is to figure out how many numbers there are, so please make sure you do it correctly. Okay, numbers can be tricky sometimes. So I would replace this with a 61. My thing down. There it is. Okay. Have I convinced everybody that there are 61? Okay.
Can we use calculators on our test?
Yeah, you could. I don't need to. 30 times 40 is 1200, and then 0.5 times 40 is 20, so that would be 1220. Good. Find the 30th partial sum. When it asks for a 30th partial sum, what is it saying to you? What's that? So add up 30 terms in the sequence, right? So that's giving me my n. I now know in this one, I don't have to do the counting thing. I now know n is 30. Okay. I also know a sub 1. So when I'm thinking about my formula for a series, I'm doing the sum of the first 30 terms is equal to 30 divided by 2 times 78 plus, and I'm going to need that 30th term. You have a couple of ways to get the 30th term. Probably the worst way is to go 78, 76, 74, 72. So why not write a rule? We know that the common difference here is what? Negative 2, so I'm going to write negative 2n. And certainly negative 2 times 1 for my first term is going to give me negative 2. That is not my first term. What will I have to add to negative 2 to get 78? Plus 80. So then I can use that to find my 30th term. And that should be 60. And I can plug that in right there. No, 20. Whew. Sorry. That's the first time I made that mistake. You have a question?
No, I'm fine.
Or you're appalled that I can't do math?
No, you didn't even ask me. He just said that.
If I were going to do this one without a calculator, these are really easy to do without a calculator today. 15 times 100 is 1500, right? And then you don't have 2 of them, so subtract 30. 215, so 1470. Cool. Okay, could you please find, you had a rule on your little card, could you please find the 20th term using your rule? The 20th term using your rule that you had written down. What is the 20th term of your sequence? If you have card A, your 20th term should be 71. Card B is negative 51. Card C is 96. And card D is negative 85. Could you please find the sum of the first 20 terms on your card? See if you can get the correct sum.
Good morning, P14. Can I please understand this? It's a pleasure to be here.